In this tutorial, we shall explore some advanced modeling and analysis techniques at TRISCO. We shall continue from the geometry developed in the previous tutorial where we learned to import geometry from the DXF file and run the analysis in TRISCO. We shall convert this 2D thermal bridge between the wall and the roof into a 3D thermal bridge using various transformation tools at TRISCO. Then we explore the difference between superposition and juxtaposition arrangement. Lastly, we learn about node boundary conditions, which would also be similar to border face boundary conditions and material face boundary conditions. At the grid menu, first, create a minimum grid. Next at the blocks menu, choose revolve 90 degrees. Then, we need to define the axis of revolve. In our example it's the z-axis. Axis position allows us to place the axis. X minus means the axis must be located at the lowest value in the x direction. And X plus means the axis to be located at the highest value in the x direction. In our example, we need to place revolve axis at the highest value in the x direction and the lowest value in the y direction. Hence, we choose X plus and Y minus. Once you click on OK, we get the desired geometry. Here you can also notice additional blocks and grids have automatically been created in order to incorporate the geometry. We shall now create a mirror of this geometry. Select all blocks holding Shift, now click on the last block at the bottom. Then choose Copy After, so we create a copy of this exact geometry overlapped with the existing geometry. We will now move these blocks to distinctly see the initial and copied geometry. At blocks choose Transform Coordinates, then choose Translation. In our example, since the maximum grid in the x direction is up to 1370 mm, we shall move the geometry a little more than this, say 1500 mm. Once you click on OK, you can notice the geometry displaced. Now we need to flip this geometry. Using shortcut Ctrl+F, we open Transform Coordinates and choose Scaling. Along y-axis and z-axis, the scaling factors would be 1 and the scaling factor along x would be -1 as we wanted to flip in x direction. We once again need to move the geometry in x-axis by a distance, say 5000 mm, so that the copied geometry would be on the other side of the initial geometry. Now, we check what is the grid dimension in between the geometries. In our example, it's the X grid 96 to 97 with a length of 760 mm. Finally, using Transform Coordinates, choosing Translation, we input the translation distance in X direction with -760. We now achieve the mirrored geometry as desired. Save your file as we will create a new project now and get back to this file shortly. At the new project file, we shall create a simple I-section beam which we will later import into our initial file. To create the I-beam, we will create simple 3x3 grid meshes in XY plane. Choose the mesh in X-axis and click Insert After for 2 new meshes. Similarly, insert 2 new meshes in Y-axis, by clicking on Insert After. At Blocks window, we will now create a block for the top flange, so input the Y max as 3. Create a new block, by choosing Insert After. We will now create a web with grid domains, x min equals 1, x max equals 2, y min equals 1 and y max equals 2. We now create another block for the bottom flange with grid domains, x min equals 2, x max equals 3, y min equals 0 and y max equals 3. Finally, we input color 13 representing steel for all the blocks. We now give realistic dimensions to the I-beam. If we want our web to be 200 mm, we shall change this second mesh along x direction to 20 cm. Next along y direction, change the first mesh dimension to 10 cm and third mesh dimension to 10 cm. We shall increase the height in z direction to 100 cm. Since our previous project was in millimeters, we shall change the grid dimensions of the current project to millimeters. At the Grids menu, choose Grid Unit and then input 0.001. Then TRISCO asks if we wanted to transform grid widths and choose Yes so the object scales to the new dimension. Save the project and open the previous project. Click on the last block so that the geometry we import will be placed at the bottom, then from the Blocks window choose Insert File. Now from the saved location choose the I-beam we just created. The beam is now inserted in this project file. Using transform coordinates, we will move the beam intersecting the roof slab. The displacement of geometry at the x direction is 800 mm, at the y direction for 200 mm and at z direction for 800 mm. At the image window click on Show BCs to visualize boundary conditions. We can increase the height of the outdoor boundary so that it would envelop the beam. At the block window, for first block with color 171 we input the maximum value for Z max, which is 102. Now, at the image window choose Back Show Materials. As we discussed earlier, the blocks are arranged in the principle of superposition. Here blocks overlap over each other, and at the area of overlap, blocks with higher priority preceded lower priority blocks. In our example, beam supersedes the roof at the area of the intersection. Using right-click, click on the web and then click on Select, next you click on Flange and then click on Select and then the remaining flange. Now once all these three blocks are selected, using transform coordinates we move 150 mm in x and y direction. Once we move, you do not notice any void created at the beam's previously located position, and using the principle of superposition the beam has superseded over the slab at the new area of intersection. Whereas if the blocks are arranged in juxtaposition, then the blocks of higher priority trims and completely remove the blocks with lower priority at the area of intersection. At the Blocks menu, choose Arrange Blocks. Then we can change from superposition to juxtaposition. Now if you perform a similar operation, select the three blocks representing the beam and then using transform coordinates, if we move back -150 mm in x and y direction. You notice a void have been created as we arranged blocks in juxtaposition. If the beam is not seen, then select the blocks of the beam, click on the last block and choose Move After. To fill the voids with blocks, at the Blocks menu, choose Fill Voids with Blocks. Then enter the color you want to fill the void with. Suppose color 13. Now you see the voids fill with a new block. Towards the right you can also see a void filled for external boundary conditions, because at beginning, we only raised the height of the external boundary condition towards the left to envelop the beam. Now, undo the fill void using Ctrl+Z. At Grid menu choose Auto Split, for grids up to 50 mm split into equal grids of 10 mm each, and for larger meshes, split at an increasing ratio of 1.5. Now at Edit, choose Node BCs, which stand for Node Boundary Conditions. Here we can input a temperature or power at any particular node generated within the grid. To view as coordinates in the Grid window, at Edit menu choose Coordinates. Now you get the absolute grid index for us to select the required node. Say we wanted to pick node x equals 5, y equals 30 and z equals 5. Then input the node temperature, say 50 degrees. Now, if we run the analysis using Calculate, we get the heat flux generated using this node BC. This could take a bit time to calculate as there are a large number of nodes and inputs. Similarly, you can also find material BC to input temperature for a material, or you can also find border face BC to border faces between colors having a fixed temperature or heat flux. Thank you for watching.